Okay, June 2018, higher tier paper 2, part 2. So starting with question 11, we've got large triangle split into two, creating two right angle triangles. We know the area of triangle ABD. We're asked to find the angle X in triangle BCD. Okay, this is an OCW question, so setting out your work carefully and explain everything you do is important. So using the area of triangle ABD, we know the base of the triangle is 5, the height is dB, which will be useful to help us find x, divided by 2 equals the area they give us, 35. So rearranging that, 5 times dB equals 70. So dB would be 14 centimeters. That's 70 divided by 5. Make sure you put units in to get your full OCW marks. Okay, so just setting that up would be worth 1 mark. Coming up with the correct answer of 14 gives you a 2nd mark. Mark it on the diagram so you can see what we're doing. Now, to find angle X then, we can use trigonometry in this right angle triangle. So we're using SOHCAHTOA again. This side here, the 32, is opposite the right angle, so it's our hypotenuse. The side 14 that we know is touching the angle, so that's our adjacent. So adjacent and hypotenuse, we're using cos. So in triangle BCD, we know that cos of the angle X is equal to the adjacent over the hypotenuse, so 14 over 32. Again, writing that down will get you a mark. And then to find X, the angle, we have to use inverse cos. So X is cos to the minus 1 of 14 over 32. That's another method mark. Typing that into your calculator, you should come out with 64 degrees for your final answer mark. And then it's 2 extra marks for making sure its organisation and units, things like that, are all correctly placed, showing all your workings out. Okay, question 12, rearranging formulas. There's 5 marks for this. Okay, we've got to give it, make C the subject of the formula, and C is in 2 places in this formula. So we need to gather those C's together to be able to do this. But the first thing we need to do is to remove this D at the bottom. So it's dividing by D, we need to take it across and multiply. Okay, that would be your first step, and that's your first mark, just writing that down. Expanding the brackets then will get you your 2nd mark. So DC minus 5D equals 3C minus 7, and you've got 2 marks. Right, now we need to collect the C's together. We've got a C on the right hand side and DC on the left hand side. So we need to bring that 3C over. So we're going to have DC, 3C comes over, becomes a minus 3C. And at the same time, we'll take this minus 5D over to this side and it'll become plus 5D, and we've still got minus 7. That's your 3rd mark. Now, if we want to make C the subject, we need it on its own. So as we've got 2 terms with C in, we can take it out as a common factor, C, open brackets, D minus 3 equals 5D minus 7. There's your 4th mark. And then, because obviously C is multiplying this bracket, we can divide through by this bracket, so we get C equals 5D minus 7, all divided by D minus 3. And that is your 5th mark. Okay, question 13. Another 5-mark question. Okay, again we've got a triangle, got 2 sides and we've got an angle. They want us to work out 2 things, the size of BAC and the area of the triangle. Now, we're using trigonometry, but it's not a right angle triangle, so this isn't using SOHCAHTOA. It's either using cosine rule or sine rule, both of which are given to you at the front of the paper. Okay, here you've got the sine rule, cosine rule, and also area of a triangle using trigonometry. So let's start with BAC. So B to A to C, this is the angle we're talking about here. Okay, now this is opposite the 6.4, which is useful for us, and this 5.3 is opposite the 4.6. So because we've got a pair, a matching pair of side and angle, we're going to use the sine rule. So sine of A over 6.4 is equal to sine 46 over 5.3. Okay, we need to find A, so we take 6.4 to the other side, becomes times. Okay, so that's what sine of A is equal to. To find A, it will be inverse sine of all of that. Okay, so what we do on our calculator, let's move this up. Let's work that part out. Okay, so 6.4 times sine 46 all over 5.3, okay, which is 0.8686, etc. Don't need to write it all down. So on your calculator then, to work that out, shift sign to bring up the sign to -1, press the answer button, and it will put that previous answer in, close brackets, equals, you can see 60.3. Okay, so there's 3 marks for this part. 1 mark for setting up using the sine rule, 1 mark for rearranging there, and 1 mark for the final answer. Now, the area of the triangle, again, remember this is given to you, the formula at the front. So area of triangle ABC. The rule is half AB sine C. Now, it doesn't really matter which side's A, B and C. The point is, this is the angle in between these 2 sides. So if we look at this angle here, we've only got 1 side because we haven't got that one. Same here. But for this angle here, we've got the 2 sides either side. However, we haven't got the angle. But now we know A is 60.3, we can work out angle C by taking the 2 angles away from 180. So 180, take away the 46 and 60.3, and that's going to give you 73.7. So that's the angle we're going to use. So we've got a half times 6.4 times 5.3 times sine of 73.7. Typing that onto your calculator, 16.3, and it's an area centimetres squared. 1 mark for using the formula correctly with the right numbers in, 1 mark for the answer. Okay, and that's the full 5 marks. Okay, on to question 14. So we've got 2 rectangles, one inside the other, shaded area, and all the measurements are correct to the nearest centimetre. Notice how they put that in bold. It's obviously important. This indicates to us straight away that we'll be using upper and lower bounds. Now, we want to find the greatest possible area of the shaded region. So if we want this shaded region to be as big as possible, we want the outside rectangle to be as large as possible, but the inside rectangle to be as small as possible. So we want the max area of the large rectangle and take away the minimum area of the small rectangle. Okay, so if these are to the nearest centimetre, it's plus or minus 0.5 centimetres to each measurement. So maximum here would be 31.5, and here 23.5. And we'll take away the minimum of these. The minimum of 21 would be 20.5, and a 13, 12.5. Each one of these is basically worth 1 mark. Okay, so there's 2 marks for that statement. Type it into your calculator. You should get 484 centimetres squared for your final mark. Now, here we've got a question about transformation. The transformation has already been done from A to B. We have to describe it. Now, we can see shape B is smaller than shape A, so any change in size means it's an enlargement. That's enough to get you 1 mark. What we need next is the scale factor. So it's an enlargement by scale factor. Well, we can see it's half the size. For example, here, that's 2 squares, that's 4. But we can also see it's been spun round and it's upside down. That means it's a negative enlargement. So it's a scale factor of -1/2. That's your second mark. So 1 mark for the word enlargement, 1 mark for the correct scale factor. The final thing we need is the centre of the enlargement. Now, to find this, what we do is we draw lines from the corresponding corners of each shape. So if I start with this corner, for example, that would match up to this corner here on shape B. If I join that up, and then do similarly for this corner, which would correspond with here on shape B, where those lines cross, here is your centre of enlargement. Now you can do that with any of the corners, so if I use this corner as well, for example, that matches up here. If I join those up, you can see it also goes through that point. So it's worth doing at least 3 lines just to make sure you've got the right centre. So that point then is just 7, 4. So centre, 7, 4, and that's your 3rd mark. All right, question 16, probability. So you keep saying lots of probability questions on these papers. We've got 3 days, probability Monday, Tuesday and Wednesday. On each day is 80% chance of raining. Part A, calculate the probability that will rain on all 3 days. Now this is obviously a use of and, okay, because we want it to rain on Monday and Tuesday and Wednesday. Now the other difference here is they're using percentages rather than fractions or decimals. When we're multiplying these probabilities, then we either need to turn them back into fractions or decimals. We don't want to leave them as percentages. So 80%, so decimals, 0.8, 0.8, 0.8, or if you just like 0.8 cubed. So multiply that, we get 0.512. Okay, 1 mark for the method, 1 mark for the answer. Now in B, calculate the probability that it will rain on exactly 2 consecutive days. So we've got 2 options here. It could either rain on Monday and Tuesday, but then not Wednesday, or it could rain not on Monday, but it could rain on Tuesday and Wednesday. So, raining on Monday, we know it's 0.8, times Tuesday, again 0.8. If it's not raining on Wednesday, that's 0.2. Multiply those, 0.128. The same for this way around. If it's not raining on Monday, 0.2. Raining on Tuesday, 0.8. Raining on Wednesday, 0.8 again. And again, that's 0.128. But of course, because it could be this day or this day, we need to add those two together. So 0.128 plus 0.128 gives us 0.256. Okay, so again, 1 mark for doing one of them. If you do both, 2, and a mark for your answer gives you the full 3 marks. Question 17. So we've got negative and fractional indices. So negative indices, remember, just mean 1 over the positive indice. So if we apply the negative first, that will give us 1 over w to the power of 3 over 5. And fractional indices are roots. The denominator, the bottom part of the fraction, is the root. So over 5 here means it's the 5th root. So 1 over the 5th root of w. But the top number, the numerator, means it's still being cubed. So that gives us this one here. 18, solving an equation. Now, we've got a fraction here, 7 over 5x minus 3, but we've also got x over here. So the way we'll deal with this is by taking that 5x minus 3 over to the other side and multiplying by the x, and it will give us a quadratic equation. Okay, so just bringing that over gives you your first mark. Expanding the bracket, 5x squared minus 3x equals 7. Okay, second mark. And then we need to rearrange this, because if we're ever going to solve a quadratic equation, it always needs to be set equal to 0. So 5x squared minus 3x brings 7 over minus 7 equals 0. Now, they ask us to solve it to 2 decimal places. So that tells us straight away that we're using the quadratic formula. Again, this is given to you on the front page. Here it is, x equals minus b plus or minus b squared minus 4ac over 2a. And you get your first mark for substituting the correct values into that. So 5 is the a, minus 3 is the b, minus 7 is the c. So you're going to get x equals, so minus b, because it's already minus 3, minus minus 3 plus 3, plus or minus the square root of, so b squared, remember b is minus 3, so we've got minus 3 squared, take away 4 times a, which is 5, times c, which is minus 7, all over 2a. So 2 times 5. Substituting those values into the formula gets you a mark. Now the next mark is for correctly working out what we've got here inside the square root. Don't square root it, just work out this minus 3 squared minus 4 times 5 times minus 7. So if we do that on our calculator, we had minus 3 squared, take away 4 times 5 times minus 7, 149. So 3 plus or minus the square root of 149. 2 times 5 is 10, and that's your second mark. Now the final mark are for the answers, and you have to get both answers correct to get the final mark. So we're just separating this out into the plus and the minus. So x is either 3 plus the square root of 149 over 10, or x is 3 take away the square root of 149 over 10. And they want both answers to 2 decimal places. So again, just using your calculator, set up using the fraction button, make it easier. 3 plus the square root of 149 over 10. Turn it into a decimal, 2 decimal places, 1.52. And for the second one, exactly the same thing, except for we're subtracting. So 3 take away square root 149 all over 10. Turn into a decimal, minus 0.92. And both of those correct gets you the fifth and final mark. Okay, question 19. Awkward little question. Give an example to show the square of an irrational number is not always rational. Now, the most common type of irrational numbers that we think of are the surds, square roots. For example, the square root of 2 is irrational. Now, if we square that, multiply it by square root of 2 again, we get 2, which is rational. What we're trying to show is that isn't always the case. So there are other irrational numbers we could use. Pi is an irrational number. So if you take pi, you square that. Well, pi times pi is just pi squared, and that is irrational. Anything with pi in would be irrational. But other roots are also irrational. We know square roots are, but cube roots are also irrational. So rather than using a square root of 2, we could use, say, the cube root of 2. If we square that, we times it by the cube root of 2 again. And using our rules for surds, that's simply the cube root of 4, which does not come out. So again, that is irrational. So both of these are examples of the statement that the square of an irrational number is not always rational. Put any of these in, either of these two in for your answer. Part B, find 2 different irrational numbers to make the answer to the calculation shown below rational. So we want to multiply 2 different irrational numbers so the answer is rational. So assuming here we're multiplying 2 irrational numbers to make a rational answer, but they were the same, we kind of come up with the same idea, but with 2 different numbers. So really what we want to do is to come up with 2 different square roots that will give us a square number when we multiply them. So for example, if we multiplied 2 and 8, square root of 2 times the square root of 8 is the square root of 16, which is 4, which of course is rational. There are other examples of this. You could have square root of 2 times the square root of 18, square root of 36, which of course is 6, and again rational. I'm sure you probably could find some more. Just 1 mark each for A and B here. Now, question 20 is all about transformation of graphs. They give us this original graph, which is a cubic graph, you can tell from the shape, marking 2 important points, -2, 2 here, and 2, -2, and the fact that it goes through the origin. But what the question has, are lots of different transformations of that graph, and we have to identify it to the correct function. So if we look at the first one, basically compared to the original graph, you can see it's been reflected. This point here was originally up here, and here, same thing. So there's been a reflection in the x-axis, which basically means it's altered the y-coordinates. It's changed the signs of the y-coordinates from 2 to -2, and here from -2 to 2. So if it's altered the y-coordinates, that means it's affected it outside the bracket, okay? And it's made everything of those negative. So it's this one here that matches up. Now, the second one is done for us. So on to the third one. Now here, if we compare it to the original graph, you see that? Everything has dropped down 2 squares. The y has gone from 2 down to 0, and here it's gone from -2 down to -4. So there's been a movement in the y by down 2. So affecting the y coordinates outside the bracket, and down 2, top one there. Next one, number 4 here. This time the movement has gone across. The x values have changed. This was 2 initially, and it's gone across to 0. This was 2 initially and gone across to 4. So it's gone across that direction, 2. Now, if it's affecting x values, that's inside the bracket. But of course, if it's inside the bracket, it's the opposite operation. So rather than +2, it's going to be -2. So that's there. And then the final one, what's happened here is all the y values have been multiplied. It's gone from 2 to 4, and here it's gone from -2 to -4. So the graph has been stretched, okay? The y values have been multiplied by 2. So again, if it's affecting y, it's outside the bracket. Everything's been doubled. So it's there. And finally, question 21. Right. Basically, we got a use of Pythagoras in a three-dimensional shape here. We know this diagonal from corner to corner is 20. We know the sides of the cubes in all directions are x. And that's what we have to work out. We need to work out x. So if you imagine this triangle here, we could use Pythagoras, but we don't know this diagonal. So we need to work this out first. So if I call that y, that obviously there is x as well. And what we've got, using Pythagoras for that, is that y squared is equal to x squared plus x squared, which is 2x squared. So when we come to use this triangle, we can now replace that y, if you like, for what we just worked out, 2x squared. So what we've got is x squared plus 2x squared equals 20 squared. Okay, sorry, let's get clear. This line is not 2x squared. This line is y, but y squared is 2x squared. So x squared plus y squared equals 20 squared. And of course, y squared can be replaced with 2x squared. X squared plus y squared equals 20x squared. And y squared can be replaced with 2x squared. So altogether here, we've got 3x squared equals 20 squared. So x squared, well, 20 squared is 400, divided by the 3, square root that to get your answer, and it's 11.5. In terms of marks, that will get you your first mark. Okay, then using that 2x squared in this will get you your second mark. Okay, third and then fourth mark. Okay, finished.